So, hello everyone, it's me again, video number 3. In this video we're going to test this really basic network, and to do that we will have to change some things. First of all, I did one mistake that I know in the last video. Here we have to say plus equal, and now to test the model I actually want to use another activation function. We have here a boolean activation function, and what I want to do is to be able to use float. So what I'm going to say I want to create another function, and we're going to get a float, and all I want to do is to say return data divided by 10. And why is that? With research and time, it so happened that artificial neural networks tend to work better when the values are between 0 and 1. So if we want to give greater numbers than 1, then we compress the data. That's why I call it compress. I use 10 because the data I want to use, we can use more. And now let's start writing some code. So what I want to say is create a setup and create a loop, which is in processing called draw, and I want to initialize our neural network node. We call it NN. And why do I get? Because we call it nodes. I forgot the S, and here we're going to say NN equals new nodes, and we're going to set the learning rate to 0.01, and let's say we want to have 5 elements. Okay, so this is really basic. Usually in neural networks we use data sets of thousands of data points, but now we just want to check I just want to check if it's working before I'm doing all the connection to Arduino and creating a data set from the Arduino. I just want to see if it's working. So let's create a simple data set, and what I want to do is I want to see if I can train the neural networks to do some basic calculations. So I will create a data set of inputs with two-dimensional array, and let's say semicolon, and we're going to say like 2, 3, 5, and let's copy that 5 times. We can make it larger if we want, or if we see that we need to. And let's say here 1, 4, 3, 2, 7, 4. Let's say 5 6 1 and let's say 6 2 4. So, and the targets will be a one-dimensional array and it will be the result of 2 plus 3 plus 5, it's 10. Then the next one is 8. Then we have 13 and we have 12 and we have 10 again. Okay, so let's change that. Change that to, let's say, it will be 9. So in order to be 9, make it 3. So now we have a really basic data set. Actually, it will be cool if it will be able to learn how to calculate from such a simple and small data set. So now here we have to train it. So I'm going to say for int I equals 0, I is less than 5, I plus plus, and we're going to say and that train model, and it will be inputs I and targets I. And there's targets and not target. Train model, the function train model except parameters. Okay, so we change everything to float, but here we have to change this to float, and also here and here, and here. So now everything is supposed to work nicely. Okay, so now if we activate it, we're gonna see, okay, we have here, it have to be 3, and probably over there also it will be 3. Now I'm just hard coding it. Later we will make a variable. So now it's working, but we don't see anything. So let's create some basic graphics that we can see everything. So first of all, let's make a window with a size of, let's say, 600, 300, and let's make a variable that will be, we'll store the predictions. We will call it predictions. It will be an array of floats. Now I'm hard coding everything. Later we will make it more sophisticated, and we will make an index. Index will be integer. So now I want to get all these outputs and here I want to use the new function compress. How did I call it? So here. So now I want to say prediction index equal output. And I misspell my own predictions. Okay, and we will say index plus plus, and we will say if index equal this that nodes index equals 0. So what did I do here? It's just like I created a variable, an array with 5 elements, and every time the function is activated, we get an output. So I'm storing the output in the predictions and updating the index. When we reach the limit of the array, I set the index to 0, and then all the process is beginning from the start. So now it's supposed to be able to display this on the screen. So let's say background 0, and we will say text size, let's use 18, will be enough, and let's get a color of something like orange, or now we will say for int I equals 0, I is less than predictions that length I plus plus, and we will just predictions let's say I will change it later to something shorter. And now what we have to say, we want to see the values on the screen, so we're going to say text predictions, and we're going to put it 20 plus I times, let's say 100, and let's say we'll put it here, and expect like int float, and what did I have here? Predictions I. Yeah. So let's see. Now we're supposed to be able to see the results, and the result that we're supposed to get are 10, 8, 13, 12 and 9. Okay, this is really amazing. I was not expecting such a result. Okay, so to keep this video short, we will stop now. In the next video, we will build some interface to introduce our model with new data that it didn't see after we train it. And then the next step will be to start with all the Arduino stuff, loading data. Actually, what I want to do is to use a linear actuator that I'm building and train a model to calculate at what power to move the engine to reach a certain destination in a certain time. So this is my idea how to test an Arduino problem, which will be very interesting because we can make it really, we can go in many directions. We can put the RPM of the motor, the threads, the distance of the threads, and we can get really, if it will work, and I believe it will work, we can create a model that will be able to help many Arduino problems, many robotics problems. So I'm looking forward to that. If you like, give a like. If you have any comments, any questions, please ask. And I will see you soon in the next video.